We're going to tackle the wishy-washiness of numbers in a measurement system analysis today. Wishy-washy. That's a real statistical term, by the way. Statisticians never commit to anything 100%. Now back to the topic at hand. Measurement system analysis, or MSA, is a great way to evaluate the major sources of error in your measurement system. For a small investment in time, you can get a lot of statistically valid and useful information. Now, as you were taught in class, the default size of a standard gauge R&R, repeatability and reproducibility study, is either 2 or 3 operators, 2 or 3 repetitions, and 6 to 10 parts. Let's talk about this 2 or 3 business today. Number of parts we'll deal with in another episode. So let's first deal with operators. Now, just as a reminder, operators impact our estimate of reproducibility error. Now, I put operators in quotes because sometimes you're actually comparing actual gauges. You might have an existing automatic gauge and now you're buying a new gauge and you're going to use both. With that new gauge, are you going to introduce more measurement uncertainty into your data? Or maybe you are replacing your older gauge. You want to compare to see if there's any sort of bias and other possible errors between the two. In a controlled manner, such as a Gauge R&R study, 2 gauges are fine to detect differences. If you have 3, even better. Now, in some instances, you might have even more than 3 gauges. Just pick 3 at random from your population. But sometimes operators are truly human beings. Can you get away with 2? Absolutely. But I always like 3 for a couple of important reasons. One, if you have only 2 and they are different, it is possible that somebody's right and somebody's wrong. Actually, both can be wrong. But you don't know who. With 3, if one person is different from the other 2, that one person might not be wrong. It could actually be correct. But at least you can start asking intelligent questions about why that person is different from the other 2. Secondly, if you have 3, then you can test some additional hypotheses. So there's a couple of scenarios here where I always like to use 3 operators. The first one is this. You have a subject matter expert. Then you just take 2 operators at random and that subject matter expert. Do they show up different? If reproducibility is a problem and at least one of the operators is different from the subject matter expert, then that is a measurement process opportunity. But here's the deal. Problem will be there forever unless you fix the measurement process. Great constant in life is people change positions. Just because you train someone and get them up to speed, that person will move on, a new person comes in, problem comes back. Now, the second scenario is where I've had a couple of gauges in my career where the process is sensitive. Some people believe the results are highly operator dependent. You can actually test that theory. And here's where I employ 3 people. The first person is that subject matter expert. The second person is somebody who really cares and they follow the procedure exactly. They want to do a great job. And that third person is somebody who really doesn't care. They might actually care, but they play like they don't. Our team members are incredibly busy. They do not have the time to be careful. They need to walk in, put the part in the machine, push the button, and walk back to the floor. If you insist that a team member needs to be gentle in the measurement process each and every time, You are very naive. I promise that you have a lot of reproducibility error in your process. So I'll test for it. If someone who doesn't care, subject matter expert, can generate the same values, I sleep at night knowing I can trust the accuracy of my data. Bottom line, if you can get three operators, great, do it. But if you only have two operators, still trust in the statistical power, and that's sufficient. While you have that one resolved, please like and subscribe down below. Thanks. Now, as for 2 or 3 repetitions, it's really kind of the same argument. If you ran all three and all three are similar, great. If there are patterns, look hard into the patterns, whatever they might be. But even if you ran 2 repetitions and repeatability error is large, you start by asking the right questions. You can still get valuable information with 2. So bottom line, the beauty of statistics is that if done the right way, it doesn't take a lot of data to get meaningful information. You can run 3 operators or 3 replications, do it. But certainly do not go beyond that. More doesn't help you at this point. Likewise, if you can only do 2 operators, 2 replications, you're still going to get meaningful information. Ain't statistics grand?